Four witches made quite a commotion when I invited them to make a potion. Into the 4 glasses went the magic brew.
Dr. Carell poured the magic brew.
And into a rage the first witch flew. She shrieked,
"There is no magic in my drink. To cast a spell, it must be pink."
The second witch laughed.
Ha ha ha. The pink is here. Pour your brew in. The color will appear.
Pour yours into there.
Amazing.
The third witch shrieked
We need more.
and gave her brew to witch number 4. Yeah, I haven't gotten enough to think about warlocks. Right. Now there are 2 glasses of pink, but no one asked me what I think. I'll invoke my powers to make it clear. Be gone, pink. Watch it disappear. Disappear. I didn't have quite enough magic. Okay. Hang on.
Good one, Dr. Carell.
There's the magic card trickle over.
Yeah. Yeah. As Act 1 finishes, Dr. Carell gets
One more show today. All right, so here's what was going on there. In beaker 1 and 3, I had put a few drops of phenolphthalein before we started. Phenolphthalein is a pH indicator, which is clear in acidic or neutral conditions and pink in basic conditions. In beaker number 2 and beaker number 4, I had put a little bit of ammonia in it. So when we poured the liquid with the phenolphthalein into the ammonia is a base, so it turned pink. In the end, the big beaker had some vinegar in it. And so when they poured the pink back in, vinegar has what acid in it? Acetic acid. So when they poured the liquid into the big beaker with the vinegar in it, the acetic acid neutralized the ammonia, and therefore it went back to neutral and it went back to clear. So that was the chemistry behind that demo. Okay? Mr. G?
Alright, it wouldn't be a Halloween demo show without dry ice.
Dr. Carell, did you get my email? Okay. Okay.
Alright, so let's talk about the composition of dry ice. What is it? Carbon dioxide.
Frozen carbon dioxide.
Solid carbon dioxide. Very, very good. Why do they call it dry ice?
Because it
Because
doesn't
it sublimates. Very, very good. So what does sublimate mean? What process does that describe?
solid.
Solid directly to gas. Very, very good. Okay, so I'm going to drop some of this dry ice into this large graduated cylinder filled with universal indicator. How many of you have used universal indicator before? No, never in biology?
I think it's something I think.
So it turns blue. This is a solution of sodium hydroxide. What color is the universal indicator in a basic solution?
Purple.
Purple. What color is the universal indicator in an acidic solution? This is hydrochloric acid. So I want you to watch this. This is just regular tap water. Water has a pH of?
7.
What did you say? 7. It's a pH of 7. So this is a neutral pH. It's green with a neutral pH. So I'm going to pop this dry ice in the water. So what's happening once I drop it into the water? It's making bubbles. What are those bubbles? Carbon dioxide. Very, very good. What's the smoke coming out the top?
Carbon dioxide.
Carbon dioxide gas, some of it, but it is also water vapor that has condensed. So it's almost like a cloud. Why would the water vapor in the air condense in this particular case? It's very cool. Very, very cool. What are you noticing about the color of the water?
Coming orange.
It's becoming orange So is that closer to the
Red.
color of the hydrochloric acid or of the sodium hydroxide?
Hydrochloric acid.
So why does that happen? Why do you have a pH change in that
Water.
particular? Go ahead.
The water becomes more acidic.
How? What's formed?
It's forming carbonic acid.
Very, very good. Right up here. Carbon dioxide gas reacts with liquid water to form carbonic acid. So when your parents tell you that soda will rot your teeth, obviously soda has a lot of sugar in it, but it also has some carbonic acid because of the dissolved carbon dioxide and some phosphoric acid. Any questions about that? Yay!
All right, now Dr. Lee.
Alright, so this is a pretty spectacular reaction. Okay, we have a little bit of green liquid here, and we are going to make our own toothpaste.
Oh, elephant toothpaste.
Elephant's toothpaste. So if you were to brush the teeth of an elephant, you would need a lot of toothpaste. Okay, so I'm going to pour my catalyst in here. Ooh. Ew. Oh, it's yellow. Oh no. Me too. Okay, do you see it smoking kind of? Yeah. So here's what's going on. We started with hydrogen peroxide. Okay, hydrogen peroxide is the stuff, sometimes you use it on cuts, sometimes you use it to bleach your hair. And it is aqueous, meaning dissolved in water. And this is a catalyst. We add a little bit of potassium iodide, and it causes this to break down. So you break it down and you get water and oxygen gas. So that's what's in the bubbles, is the oxygen gas. And it's a very energetic reaction. It's exothermic, so it gives off heat. So that is why you see steam rising, because the oxygen, it's hot, and it's boiling water. Okay? And that's elephant's toothpaste.
That's elephant's toothpaste. All right, so you can say that. All right, so this demo is called Old NASA. And so it's named after NASA Hall at Princeton University. It was actually discovered by some Princeton University students. So a little bit of the history of Princeton University. You should know this since you live here. Princeton University, I may get the year wrong, but I think it was founded in 1684. It was founded when King George gave a grant of land to the House of Nassau to start a college here. All right. Now, the House of Nassau. What do you think the colors were of the House of Nassau?
Orange and black.
Orange and black. Okay, and so that's why this one is called Old Nassau. All right, so I need, this is A. Now this is going to have two reactions that are going to happen pretty quickly, one right after the other. So don't look away after you see the first reaction happen. Right? Can you all see the beaker? Because if you can't see the beaker, I can't do this again.
Whoa.
What were the colors?
Orange and black.
There you go. That's Old Nassau.
Okay, I need 2 volunteers. Oh, you 2 ladies had your hands up first. Okay, wait, you already went.
I'll go.
Go ahead, and this lovely gentleman over here. You need goggles though, so
I'm right
grab
here.
yourself some goggles. Very, very good. Anybody else have goggles left? Grab me a pair, doctor. Thank you.
Wait, Emily.
Okay, you need to be. Oh, you have goggles already. Why didn't you say, Mrs. Jamaica, you have goggles on your face? Yeah, come back here. Mr. Everett, you need to kill the lights for me. Come on back here. Okay, you are going to hold solution number 1. You are going to hold solution number 2.
Mrs. Jamaica?
Yes.
Before you start, just reach into the back room and shut the light off in the back room.
Okay, is the pumpkin in the way?
A little bit.
And there's something.
All right, so when I say go, both of you are going to simultaneously pour your solutions into the funnel. Don't let it over the funnel overflow. Ready? 1, 2, 3, go. Keep going. Cool. Thank you. Yay. Lights.
Action.
This particular reaction reacts a compound called luminol with bleach. Luminol is an oxetane, so it's this 4-membered ring, 2 oxygens, and the bleach works to cleave the oxygen-oxygen bond. In doing so, releasing energy. In this case, the energy is not released in the form of heat, but it's released in the form of that neon light. This is essentially the reaction that happens in the glow sticks that you would get at a concert. And the first thing you would do is take that glow stick and break it, right? You'd snap it. That allows the 2 chemicals to mix, and as they mix, they react, and that produces that really nice glow. What would you do with your glow stick if you wanted it to last longer? Where do they tell you to put it?
Freezer.
Why would you put it in the freezer?
Molecules are moving
It prolongs. Why would it prolong the reaction?
It slowed the reaction.
Yeah, the molecules
Less
aren't
kinetic
moving as
energy?
fast, so they're not going to be knocking into one another as fast. Therefore, they would have lower activation energy, and the reaction wouldn't be able to happen as quickly. Very, very good.
Beat one like Arthur.
All right, so those of you who are in the front have the worst seats. Okay, we're in the back now. This is called the methane mamba. No. Nobody said move the seats because I need this area clear. Okay. So,
I'm just gonna go up.
what is the gas that comes out of the gas jets here? What is the gas that comes out of the gas jets here?
Methane.
What?
Methane.
Methane. Good. What is the gas that is in? What is she doing? What is the gas that is in your gas grills?
Methane. Butane. I don't know.
No, butane's lighters.
Okay.
Okay. Propane. Very good. Okay. Methane is C1H4. So if you look at the periodic table and carbon there, it's red. In red it says 12, right? Hydrogen's 1, so 12 plus 4 is 16. Propane is C3H8, so it's 3 times 12 is 36 plus 8 is 44. What is the main component of air? Nitrogen. Nitrogen is N2. 14 times 2 is 28. So methane is lighter than air. Propane is heavier than air. So you can't do this with the propane gas in your grill. You will burn yourselves pretty badly. So don't do this at home. All right? You know how in those car commercials, I noticed I'm taking off my watch. When I call you up, if you want to do this, you have to have nothing on your wrist. You know in the car commercials where the guys are doing the crazy driving stunts, it says professional drivers, do not try this at home. Professional chemists, do not try this at home.
Just lean down. I'm just trying to record it. Move up. Can I go forward and just lean down? No. Do you really? Sure.
You know what I forgot to bring, Miss McCulsa?
What?
The aiming flame is sitting up there. Yeah, that's okay. My mother has a childhood friend. I still know her as Sandy Phelps, even though she's been Sandy Spector for 60 years. So,
I'll be Miss McCullough forever.
all right. So, one of the safety precautions, I'm going to turn the water on over here. You want to wet your hand and your arm about halfway up your arm. Otherwise, there's a chance you'll burn all the hairs off your arm. Come on, stay up there.
I'm trying.
Anybody want me to light their hand on fire? Yeah. Goggles, line starts right here. Goggles, line starts right here. You can videotape this if you want. Put your hand out. Hand wet? Is your hand wet? You can go wet your hand. Got both hands wet? Scoop it, scoop it up. Over here.
June, move your hands apart.
Like this, facing each other. Separate them so the bubbles are between your hands. Okay, hands up a little higher. So when I light them on fire, you're going to go whoosh like this.
Could you just move?
Okay, it's going to get kind of slippery here. Let's go.
Where are you putting your hands? Right here?
Sink back there.
June, could you please?
You got to be wet. The other hand's not wet, so do it with the other hand. They're both wet. Okay.
Make sure your sleeves are rolled up enough.
Once you've gone, take your goggles to the end of the line. Oh my goodness. Once you're done, take your goggles to the end of the line. Go.
Excuse me.
Yeah, don't.
You stay here. Everyone's going off that floor.
Uh,
Go, you get wet. Stop shaking.
Ew. That's like snow.
Hands wet?
Yeah, Pasha.
Sorry.
Man, I'm trying to light my leg on fire.
Hands out. Hey guys, just a warning. If you're standing right here and your hands are low, and you swing your hands hard and you hit the table, there's a good chance of breaking your hand. Okay? So either step further away from the table or swing your hands higher.
But don't bring them up close to your hair. Just be cognizant of where your hands are.
Your hand wet? Need paper towels? There's more paper towels. Can you grab paper towels?
Excuse me.
Okay, let me explain this to you. This is my fault. Those goggles are doing a great job of protecting your chest. It's a little late.
Excuse me.
We're going to have you go again. You're not going to go now. Because your hair needs to be tied back. Go wash your hair. Dr. Lee? Or Mrs. G? Does someone have a hair tie for salon? Or do you have one? Oh, she's got one.
Gina. No, I need
Got one.
Gina.
Finish up.
Lana, come over here and wash your hands up. Hang on, just wait there.
Pass the goggles back.
Just wait there. Guys, we're done. We're done with the goggles, man. Pass the goggles on. Hey, I don't know who this young lady is in the orange shirt here.
Oh, Melanie.
Somebody's going to wing their hands and throw flame in your hair, and you're not going to be happy.
Let's go, Mary. Go, Mary. Don't die.
So now just scoop them up with your hands. Just with one hand that's wet. Okay, that's good.
Wait, so do I just like move it?
You don't have to move it. You can just hold it.
Hold it.
Just stand there. Don't move. Don't move.
Ew, why is it sticking?
Stop being weird. What? Oh yeah, yeah.
I move your hands.
Because they get threatened.
You guys see how?
Good job, Emily. You didn't move.
Those of you who have gone, go sit down. No.
Emily.
Three classes in here. We go multiple times, we never get to the function.
Emily. Emily.
Let's go back.
Otherwise, we'll run out of time to do the other things.
Zach, make a fireball. I'm taking video. Huh? Huh? I'll just take a picture, sure.
So, while we're finishing this up, why doesn't your hand get burned? Why? The water does what? What about water keeps your hands from burning?
High specific heat capacity.
The high specific heat capacity absorbs the heat.
Oh, it's that high specific heat capacity? Yeah, Zach. Yeah, Zach. Way to get a little baby back.
Sorry, there was not a very good amount of verbal. Zach, go away. You're supposed to go away once you're done. Go back there.
10 years now, nobody gets burned.
Zach, can you record while I go?
Ladies and gents, if you still have Dr. Crow's goggles, make sure they go back.
All right.
But there's the only people that want to go. Wait, Dr. Crow. No, there's some other people that want to do it. Poor little Adrian. Give us a...
I think they're all iPhone.
Ladies and gents, this one has been a little disappointing today. We had lots of issues with this solution yesterday. It's really, really fuzzy, so I'm not promising anything. But here we go. It's called Black Magic Woman, hence the Santana music. You start with a relatively clear solution. You put it in this beaker.
It's working!
We're such a special class.
You are.
Watch, just watch.
Blue.
Whoa.
Into beaker number 2.
Clear.
That's pretty cool.
Into the larger clear container.
Drink Gatorade.
That's not closed. That's not closed.
Are you gonna shake it and it's gonna go clear?
Good call, Dr. Good call, Dr.
Black magic woman. I figured it out.
Okay. Now we remember next year.
Yeah. I'm gonna write it down.
Good catch, Dr. Carell.
Alright, so this is a sodium iodide for the Alright,
Yes.
we've come to the end of our show. The pièce de résistance.
What?
Pièce de résistance.
No, I couldn't understand it.
What do you say?
The pièce de résistance?
What is he saying?
Yes, they'll have to go.
Okay.
So, well, we're going to get you guys in the front row group anyway. Alright. So what I have here is some black. You're not going to stay there anyway.
No, I'm not.
No, because you're in the line of fire.
Okay.
Well, on second thought, it might make the rest of my year easier. Alright,
I think he's joking with children.
I have to do some chemistry here. Calcium carbide is called Spelunker's chemical. What's a spelunker? Not digs.
Isn't that when you're going caves?
Goes in the caves. It's a cave diver. Okay? So calcium carbide is also called Spelunker's chemical. Water, fuel is really heavy to carry. So they don't want to carry fuel, they carry calcium carbide because in addition to rocks and dirt, what else can you always find in caves? Water. You mix calcium carbide with water, you produce some calcium hydroxide, which is not all that interesting, but you produce acetylene gas. Acetylene gas with a little flame and some oxygen goes boom, producing carbon dioxide and water. So, I will warn you, this is the one demo of the year that I do wear hearing protection.
Oh no.
Okay? Sometimes it can be rather loud. You guys need to move out of this front row. Zach, through Solana, if you're going to stay there, you need to have
Oh, you're allowed to
goggles.
be there?
No, yeah.
Zach, through Solana, if you're going to stay there, you need to have goggles on.
Oh, I just put the goggles back.
Guys, get them
Oh wait,
goggles.
just take it. I'm afraid that I won't.
How about wait?
Adrian, you're not gonna be able to stay there.
Yeah, it didn't even.
Well, he'll tell me.
Would you guys just give them the goggles? I need goggles in the front row. Thank you. Zach, you have a pair?
Pardon me?
All right. Shh. Quiet.
There's three of you on the floor over here.
They're okay.
Do you think they're okay?
Yeah, because it's going to go that way. Adrian, what did I say? Now listen. When I tell you, I will yell, fire in the hole. That means I'm about to set it off. Do not put your fingers in your ear. Because if you jump, there goes your brains. Okay? Simply take your hands and put them in front of your ears. And if you really don't like sound, cover your ears. But do not stick your fingers in your ears. All right, here we go. I'm going to do what I did last time. I put in a whole thing of this thing and then another one. I mean, I'm basically overflowing with water. All right, you timing me? Am I underneath the light? No. Good. Okay.
You want 30 seconds?
Well, tell me when I get to 30.
10 seconds.
Yeah, I will. I can't hear. You think I don't know my ears aren't
20
covered?
seconds. That was 20.
Where are we at?
25.
Okay.
30.
Okay, give me a countdown to 40.
5. Oh my God. 4. 3. 2. 1.
Fire in the hole! How was that? Was that good? That concludes our 5th annual Halloween Extravaganza! Please tip your waiters on the way back to your room.
Amazing.
As Act 1.
Whoa.
What were the colors?
Orange and black.
There you go.
Good call, Dr.
Fire in the hole! Tip your waiters on the way back to your room.